Hello everyone, today we're going to look at trig functions of any angle. So we're going to focus on finding theta between 0 and 360 degrees given the trig value. Finding the trig value is just as easy as plugging it into your calculator. So we're going to do the same thing we did before, except now we're going to have more angles to deal with, and it's not just going to be between 0 and 90, but between 0 and 360. Before we can talk about that, we're going to need to discuss something that's called a reference angle. The reference angle is sometimes denoted by alpha, sometimes denoted by theta with a subscript of REF for reference. The reference angle is the smaller, or the acute angle, between the terminal side of theta and the x-axis. There are four possibilities depending on which quadrant theta is in. So if theta is in quadrant 1, then theta itself is one of the angles between the terminal side and the x-axis, and the other angle is this one right here. So hopefully we can see that theta is the smaller or the acute angle. So theta reference, if I'm in quadrant 1, is theta. It's the same thing. If I'm in quadrant 2, then again theta is one of the angles between the terminal side and the x-axis, and the other one is this guy right here. The other one is the smaller one. It's the one that's less than 90 degrees. So what we have is theta reference is 180 degrees minus theta. So remember, the whole top half of our Cartesian plane is 180 degrees. So if I get rid of what's in red, I'm left with that blue little area. If I'm in quadrant 3, then my angle between the x-axis and my terminal side, there are two possibilities. There's this one, and there's this one. The one on the left is the smaller of the two. Again, it's the acute one. It's the one that's less than 90 degrees. So this is my theta reference. Okay. And theta reference, in this case, would be theta minus 180 degrees. I want to get rid of the top half of my Cartesian plane to get the blue angle. So I need to take away 180 degrees. The last one is when theta is in quadrant 4. So again, I have this angle here, and I also have this angle here. Now the smaller one, the acute one, is the one on the right. So that is my reference angle. To get it, I take the whole circle, 360 degrees, and I subtract theta. So the whole circle minus the red, I'm left with this guy here in blue. Okay, so depending on which quadrant we're in, we have a formula that compares the reference angle with the original angle. So I'm going to just rewrite that again. So if we're in quadrant 1, theta is theta reference, and theta reference is theta. If we're in quadrant 2, theta is 180 minus theta reference, and theta reference is 180 minus theta. So if I add the two together, theta and theta reference, add them together, I get the whole top half of the Cartesian plane, which is the 180 degrees. If I'm in quadrant 3, then I have that theta reference is theta minus 180. And then solving for theta, I get that theta is 180 plus theta reference. And then quadrant 4, again, theta reference is the 360 minus theta, and theta is 360 minus theta reference. If I add theta to theta reference, I get the whole circle, 360 degrees. Okay, so there are a couple of things to keep in mind. Theta reference is always between 0 and 90 degrees. Remember, it's an acute angle, which means it can't be bigger than 90. And you want to make sure that you know what quadrant your angle is in, and then if I'm looking for theta reference or theta, we have the two different sets of equations. So you're going to have one set on the test. I forget which one it is at the moment. It's either the equations set up as theta equals, or it's the equation set up as theta reference. So if you want to find the other one, you just have to solve this very, very easy linear equation. Okay, so you will have one set. Again, I just don't remember which one it is. Now here comes the point of why do we care about this reference angle. Let f be any of the 6 trig functions: sine, cosine, tangent, secant, cosecant, cotangent. If I take the absolute value of a trig function of my angle, it is equal to the same trig function of the reference angle. Now again, theta reference is between 0 and 90, so the trig function of my reference angle is positive, and so that's why we have the absolute value there. So we're going to use this information along with the signs, S-I-G-N-S, of the trig functions to find the correct thetas. So again, we're going to be given a trig value. We want to find the theta, and assuming our angle is not an axis angle, so it's not 0, 90, 180, or 270, there will always be 2 thetas as our answer. Okay. So we're going to start off by, well, what do I have to do to find this? So you'd have a question that looks something like, find all theta between 0 and 360 such that sine of theta is 0.225. Again, there are going to be 2 answers, one of which we'll get by using the sine inverse button. Sine inverse will give us an angle between negative 90 and 90, which is quadrants 4 and 1. Cosine inverse will give us an angle between 0 and 180, which is quadrants 1 and 2. And tan inverse will give us angles between negative 90 and 90, which again is quadrants 4 and 1. So what we do is our calculator is going to give us one answer, and then we're going to use the reference angle to find the second theta. So then we'll do this out as a full example. And again, we're going to assume that we're always looking for theta between 0 and 360. So we'll start off with the same example that I just mentioned. Sine of theta is 0.225. Find the 2 thetas that satisfy this equation. Step 1 is use your calculator. Theta 1 is going to be sine inverse of 0.225. And that's going to give us to 2 decimals 13.00 degrees. The next thing I'm going to do is I'm going to find the reference angle. So 13 degrees is in quadrant 1. So I go to my quadrant 1 formula and I look for theta reference equals, and in quadrant 1 it's just equal to theta. So whenever I start off with a quadrant 1 angle, it's really nice. It is my reference angle. Next, I need to determine what quadrant my second theta, or theta 2, is in. So this is when I look at when is sine positive. So sine of theta equals positive 0.225. So we go back to all students take calculus. Now I already have my quadrant 1 angle, so I have that one. The other time sine is positive is quadrant 2. So we have 1 and 2. Again, we already have the quadrant 1 angle, so we're going to look at the equation for quadrant 2. Quadrant 2, it says that theta is 180 minus theta ref. Theta ref is 13. So we get that theta 2 is 167.00 degrees. So we have 2 answers. We have the 13 from the first one, or not that 13, this 13 actually, and then 167. Okay. You can always check these by plugging them into your calculator. Is sine of 167.00 degrees roughly 0.225? There is rounding, so it's not going to be exact, but you should always double check it. Also double check that you're actually in quadrant 2. So let's try another one. Cosine of theta is negative 0.67. Again, the first step is to just plug it into your calculator. What's cosine inverse of negative 0.67? Sorry. don't forget the negative. This is going to give us 132.07 degrees. Okay. Notice this is in quadrant 2 because cosine is negative, so it can't possibly be a quadrant 1 angle. It is quadrant 2. So we're going to use the fact that it's quadrant 2 to find our reference angle. And our reference angle for quadrant 2 is 180 minus theta. And we get 47.93 degrees. Notice that this is in fact between 0 and 90, which means that I chose the correct equation. Next, we need to determine the quadrant of theta 2. So again, we go to all students take calculus. We have cosine is negative. Okay, so I know that everything in quadrant 1 is positive, so it can't be quadrant 1. It can't be quadrant 4 because cosine is positive in quadrant 4. The angle that I have is quadrant 2, so the only one that I have left is quadrant 3. So theta 2 must be in quadrant 3 in order for cosine to be negative. So I go to my quadrant 3 equation, and I know that theta 2 is 180 plus theta reference. Plug in my theta reference, and I get 227.93 degrees. And again, I have two answers, except of course the answer that I just wrote is wrong. That's not correct. The 132.07 degrees. So I was not paying enough attention. Double check, make sure that cosine of both of your answers is in fact negative 0.67. Again, it won't be exact because we rounded. Okay, so let's try another one. Tangent of theta is negative 2.05. First thing I'll do is hit my number with tan inverse. This is going to give me a negative answer. Remember, tan inverse and sine inverse will give you numbers between negative 90 and positive 90. The first thing we have to do here is change our negative angle into a positive one. So in order to use our equations for theta reference, our angle has to be between 0 and 360. So don't forget that to change it, I'm going to add 360 degrees to it. Okay, so negative 64 plus 360 gives us 296. Again, to 2 decimals, it's 0.00. Next, we're going to find our reference angle. So 296 degrees is quadrant 4. So we're going to use the quadrant 4 equation, which tells us that theta reference is 360 minus theta, which gives us back our 64. So whenever you're having tangent or sine of a negative number, when you do the inverse, you'll get a negative angle. The positive form of that, so the absolute value, will end up being your reference angle. So that's something to keep in mind. It's not a coincidence that these two things are the same except for the sign. Next, we need to determine what quadrant theta 2 is in. So again, tangent is negative. So we have all students take calculus. Tangent being negative means it's not quadrant 1, it's not quadrant 3. We have quadrant 4, so our second theta must be quadrant 2. So we take our quadrant 2 equation. Theta 2 is 180 minus theta. Theta reference, that should be. I thought I fixed those. Oh, there we go. And we get 180 minus 64 is 116.00 degrees. So again, our two answers, the 296, the 116, double check them, take tangent of them both, make sure you're getting negative 2.05. As another one, we have sine of theta is negative 0.75. Step 1, use your calculator, hit it with sine inverse. Again, because it's sine, you're going to end up with a negative, and we need to change that right away to be something between 0 and 360. So I'm going to add 360 to it. and we get 311.41 degrees. Step 2, find your reference angle. 311 is quadrant 4, so we're going to use the quadrant 4 equation. And again, just like with tan inverse, our reference angle should be the positive version of that negative angle that you got out from your calculator. So again, we have positive 48.59 is the reference angle. Now we need to determine what other quadrant our theta is going to be in. So sine is negative. So again, it can't be quadrant 1 because everything's positive. Quadrant 2 has sine being positive. The angle we already found is quadrant 4, so the only quadrant that's left is quadrant 3. Quadrant 3 equation tells us that theta is 180 plus theta reference. So I'll plug in my reference angle, and I get 228.59 degrees. Again, make sure you're plugging in your original reference angle, the thing that's between 0 and 90. If you plug in the negative, you end up with something that's not in quadrant 3, because you end up with 180 minus something, and that would be a quadrant 2 angle. So make sure that your angles are actually in the correct quadrants, and again, you can check it by plugging them into your sine function. Make sure you get negative 0.75 each time. So again, we have our two answers. And let's try another one. Secant of theta is 7. So remember that secant of theta is 1 over cosine. So I'm going to change this into 1 over cosine of theta is 7, which means cosine of theta is 1 over 7. So theta is cosine inverse of 1 over 7. You take the reciprocal trig function, you take the reciprocal of the number. So cosine inverse of 1 over 7. And we get 81.79 degrees. We're going to have to find our reference angle. 81.79 is quadrant 1, which means theta reference is the theta. So my reference angle is also 81.79 degrees. Then we need to determine the quadrant of theta 2. So don't forget, secant's 1 over cosine. If cosine's positive, secant's positive. If secant's negative, cosine's negative. So they have the same SIGN sign because they're reciprocals of each other. So cosine is positive in quadrant 1, which we already have, and quadrant 4. And the quadrant 4 equation is theta is 360 minus our reference angle. So we get 278.21. Okay, so again, we have the 81, we have the 278. Double check them, plug them into cosine, and make sure you're getting your 1 over 7. Or plug it into cosine, hit the reciprocal button, and make sure you get 7. Okay, so here's our last one. Cotangent of theta equals 20. So again, we have cotangent, that's not a button on our calculator. So we're going to flip both sides. So the reciprocal of cotangent is tangent. The reciprocal of 20 is 1 over 20. So theta is tan inverse of 1 over 20. Okay, so again, take the reciprocal trig function, take the reciprocal of the number. And we get 2.86 degrees. It should be very, very small. Remember, tangent is equivalent to the slope. So whose angle has a slope of 1 over 20? That's a very small number. It's a very small slope. So it should be a very small angle. Okay, so 2.86 should make sense. Again, we need to find the reference angle. 2.86 is quadrant 1. So our reference angle is also 2.86 degrees. We need to determine the quadrant of theta 2. So So again, tangent is positive. I've already got quadrant 1. Tangent's also positive in quadrant 3. The quadrant 3 formula is that theta is 180 plus the reference angle. So we get 182.86 degrees. And again, you can check it. Is tangent of 182.86 1 over 20, which is 0.05. Or, again, take tangent of it, hit the reciprocal button, and make sure you're getting something very close to 20. Okay, so I want you to practice this. Again, double check that you're answering correctly. You have 2 answers, each of which you have checked to make sure they're correct. Try it out. Let me know if you have any questions. Thanks.